Yes, hi, good afternoon. I would like to start my presentation by addressing my title. This is for the class, the Environmental Health Risk Assessment. My title is Endocrine Disruptors in comparison in respects to metal estrogens. This is for the Robert Stemple College of Public Health and for Professor Alok Dioraj. So let's talk about a little bit what are endocrine disruptors. Endocrine disruptors are chemicals that can interfere with the endocrine systems in certain doses. Specifically, endocrine system, it's in particular regards to the glands that you might have, the thymus, the pineal gland, the adrenal gland, the pancreas, anything that secretes hormones. For example, here in the PowerPoint, I'm giving examples of a normal hormone and how the cellular response interacts with normal hormone. In particular, endocrine disruptors have the ability to mimic reactions, and the receptor actually picks up these endocrine disruptors, which actually creates erroneous cellular response, which can cause body malfunctions and cellular damage. These disruptions can cause cancerous tumors, birth defects, and other developmental disorders. Also, the system that's controlled your body entirely is controlled by hormones. So basically, if you have a hormone disruptor, you're going to have major components actually have detrimental negative effects. In particular, I'm going to be talking about metal estrogen. These are metal components that bind to estrogen receptors. The chemical structure for one of the metal estrogens I'll be talking about, it's a 17-beta estradiol. These environmental metal estrogens are actually found. For my study, I'll be talking about a surface water. These chemicals are in particular found in a tributary, in a river. For example, we have aluminum, manganese, magnesium, iron, nickel, copper, zinc, arsenic, and so on. These are all considered heavy metals, and in particular, US EPA targets them due to their importance. There's a lot of issues in concern to whether storm drains, there's infiltrations from septic tanks, there's point source discharges that we have issues with. In particular, metal estrogens are inorganic metal ions that bind and activate estrogen receptors. They're implicated with the estrogen dependence of the diseases such as cancer, and in particular breast cancer and endometriosis. Particular, this is by a paper from Silva in 2012. That if you're interested in looking at, you can find out. Are these chemicals harmful or not? This is something that you might be in particular interest. I find them, and the data finds them to be harmful. Why are they harmful? Metal estrogens tend to mimic physiological functions of the estrogens, and they have the affinity to bind to these receptors. Why are they so bad? Because they mimic, and by activating receptors, they're able to make cellular responses that might be negative. In particular, they can cause breast cancer or other conditions in the future. They can cause diabetes and any genetic malformation that can contribute. It might be from endocrine disruptor, in particular a metal estrogen. When and why are metal estrogens considered hazardous? Metal estrogens include arsenic, lead, mercury, cadmium, and nickel, and these are present naturally in the environment in minute concentrations. My study will definitely touch base on the fact that not necessarily you need to have higher concentrations of a chemical present at that area. but you can find that um, low levels of chemical concentration can actually affect um, genetic mutations based upon the fact that they can be exposed to chronically. I will also be talking about how mechanisms and the pathways that these are actually would be involved in. Um, some of the contributors to all these heavy metal estrogens in the area are from the industrial processes, and they've begun into it's a very environmental concerning issue. Metals, why are they concerning? Because more and more we see that these point discharge pollutants are being seen worldwide, and these metals tend to bioaccumulate in biota, in plants, in fish, and even they tend to absorb into the soil. Um, they have toxic effects in complex parts of the body. So it's a very concerning issue worldwide. So we have to address this and take this matter seriously. The materials that I'll be talking about in particular are nickel and arsenic. I've given the representation, the chemical structure of the chemicals. Arsenic in particular is a shiny gray element with the atomic number of 33 and the atomic weight of 75. This is all information that I gathered from the CTD base, computational toxicology database. This is a very helpful website, highly reputable. I totally recommend it. In comparison to nickel, is also a trace element with the atomic symbol of Ni and atomic number 28. From my perspective, they're both considered carcinogenic, and in most forms they are toxic. I'll be talking a little bit more in a little bit more slides of how toxic and what are the total limits of exposure based upon a human. Some of the exposure routes that I'll be talking about in the paper are in particular ingestion and dermal. The exposure may be estimated using models. You can actually regulate how a person or anything absorbs these chemicals, whether through its contaminated food, water, or the liquids. Foods can contain chemical residues as well. I've given a representation of how the chemical moves along the pathway, and it actually sees how the exposure contains a potential dose, the applied dose, how it is metabolized, and how it attaches to the organ. This illustration is gathered from the US EPA, from a model that they've generated. In regards to the dermal concentration, the exposure can be from the skin, from contaminated media, whether it's from swimming, from bathing, from just being exposed to the water, the contaminated water, also from fishing, from the sediments, you can also be exposed. There's also a chemical reaction and how the exposure, it's the pathway and how it travels through the body. It has to be metabolized before, right after you touch it with your skin, and it has to be biologically effective after it takes the effect. Everything has measurers, so there's ways to measure uptake and intake. I'll be talking about soon enough, the next slides. How there are many models that we can use to measure these chemicals. In particular, my opinion, you can use computational toxicological databases to help you manage and to monitor these contaminants. But my personal favorite are the contaminant feed and transport models. I use the Ecolab from Mike Shea. So what are models? Models are a representation of what the environment and what they can be used for in order to regulate and manage decisions. EPA has a lot of food chain models as well that you can monitor bioaccumulation in fish. So it's highly important to recognize and to take in consideration how you can use these tools to gather your data and to be able to extrapolate the most important part of it. Whether you have a demographic, whether it's children, whether it's women, whether it's African American, you can actually segregate and categorize depending on your model and what you're looking for. So it's very important, and I totally suggest that you do your research based upon your model. Model is very important. The government's secondary choice sources, in particular, I've used EPA. The EPA has given me some sort of a guideline of what to follow. For example, they've given me my maximal exponential individual parameters for total concentration for how much human being drinks per day. Like for example, an adult drinks 2 liters of water, so I can use that's one of my parameters that I can include in my formula. For example, another for body weight, they have a table for normal body weight for a male, it's 70 kilograms, and for a child, it's 15 kilograms. All of this is information that you're able to extrapolate from the US EPA and from literature. Other examples that I've gathered that there's let me see, for females of how much micrograms per day the intake for food. All of these are informations that that is necessary in order to do your assessment. If we continue, the nature of the hazardous material, in particular, we are talking about a chemical that is hazardous and is considered a mutagenic. Possible side effects, possible effect sites are, for example, there's certain genes that, for example, cis381, cis447, all of these are genes that that have been investigated for estrogen receptors that activate protein kinases and they activate proliferation of breast cancer cells. Though this is just an example of what are we dealing with. If you look at these metals, they have the ability to bind and mimic these receptors, and they actually generate and deactivate protein kinases. So it is hazardous material, and it is mutagenic. Some of the government regulations, like I already said, you can go from federal governmental websites. So the most important one that I follow mostly is US EPA. I also follow FDA, ATSDR, very important, highly reputable websites to follow. For example, ATSDR, they go along with the EPA. They have 10 parts per billion for maximum allowable drinking water. For the FDA, they have a 0.5 to 2 parts per billion as maximum allowed fuel intake. So it's important. You have to have a threshold in order to convert and make your analysis work. And I totally recommend that you have to have a threshold in order to make your data flow. That's in particular, that's what I recommend. If I haven't made myself clear, my study will be based on surface water and how these contaminants affect women and children, and facts of how estrogen and the fact metal estrogens bind to estrogen receptors and how it affects their livelihood and whether they can cause a risk to the public health. The population at risk, in particular, like I already said, are women and children living near this tributary. In particular, this is the Savannah River, where the confluence of upper 3 runs in the Savannah River collide. I should have mentioned the introduction of my paper will be based upon Savannah River site. This is an old nuclear reactor from the mid ages of the Cold War, where they did a lot of pollutant discharge in that tributary. So this is in particular my point of source. How can the dose of exposure be best described to the common people to convey the idea of the hazardous nature of the selected material? Here in the PowerPoint, I've given an example in particular to arsenic. Let's say we have 4.81, this is raw data, 4.81 micrograms per liter. We have, in order to do an assessment, environmental health risk assessment, you have to calculate the integrate, the total dose, the hazard quotient, and the exposure factor. For example, to calculate the total dose, you need the concentration, the integrate, the effective dose, all that divided by your body weight. To calculate the effective dose, you need the factor, the effective dose, that you can do it in years, all that divided by the average time, like for example 365 days per year. And to calculate the integrate, you need the concentration rating with the effective dose, with the effective days of how many days, whether it was acute or chronic, and all that divided by your body weight times 365 days, whether you want to do it, whether you want to have your exponent have a constant basis. So yeah, that can give you whether your concentration based upon your child. Of course, you need to associate with that your child is going to be 15 kilograms instead of 35 kilograms. All that, these are important factors that you got to take in consideration. Your hazard quotient, of course, in particular, will determine whether you're at risk or not at risk. Then you have to characterize it. It's all these are steps that you got to take into consideration before doing your assessment. So what are the reliable resources in order to find information for the selected material? Like I already said, I've used many sources, many models. In particular, I'll stick to my one and only, the ones that I use the most. I go by the EPA. I've used EPA for many years, and I like the website. It's very easy to understand. They have papers, easy to find. Most of the allowable limits are easy to collect. Data is easy to extrapolate. They have interactive websites that you can follow. CDC in particular, I like it too as well. They have national, federal guidelines that they also use. I like to use Enhance. This is a survey where I can collect the urine, blood. I can collect survey samples, all of that information. It's easy to extrapolate. You can download it as Excel files. I use ATSDR as well. Usually you go by the frequently asked questions. Very easy to find. Total fallout limits. They have papers that I'm able to read. It's very to the point. PubMed is for me the most important of all. You can ask any question. You can look for any paper, keywords. These are sources of information that I find reliable and very easy and available for the public. That's it. I hope you enjoyed my presentation, and I hope you guys had a great semester. I've listed a series of references there, and if you have any questions, please feel free to email me. And like I already said, this is a paper I'm working on preliminary data, and like I said, if you have any questions, hopefully I'll be able to answer before the semester ends. Thank you very much, and have a great night.